All right, one last little system here to solve using matrices. I kind of like what's going on here because we see these guys are already ones. That's setting us up for success. So let's write the augmented matrix. 1, -3, 1. Then we have -1. We've got 1, 1, -1, -3. And then we have 2, 4, -3, -7. All right, so since the leadoff guy right here is 1, we'll use that guy to destroy everything below that, make those guys zeros. First, by doing R1 minus R... That is not what I say. Sorry about that. So if we do negative R1 plus R2, and we put that into R2, and then we'll also do -2 times R1 plus R3, and we replace R3. That should give us the zeros that we're looking for. All right. Again with the copying. It's -1. So negative times this first guy plus 1 is 0. Negative times -3 is 3 plus 1 is 4. Negative times 1, so -1, and -1 is -2. Negative 1 is 1. Minus 3 is -2. Now we do the -2. -2 times 1 plus 2 is 0. -2 times -3 is 6 plus 4 is 10. -2 times 1 is -2 plus -3 is -5. -2 times -1 is +2 plus -7 is -5. All right, so we need to get this guy here to be a 1. There's no way to combine things so we can turn that into a 1 like we did in a previous example, so we're just going to have to suck it up and do this. Do 1/4 row 2 and replace it. You know what? I think while I'm doing that, because I see that bottom row has a common multiple of 5, I'm actually also going to do 1/5 of R3 and replace that third row with that. You don't have to. If you see that there is a common factor in a row, of course it's coming from an equation, you can multiply or divide everything by a number and make it simpler for you. Or so then have 0. 4 divided by 4 is 1. 2 divided by 4 is going to make that -1/2. That's -1/2. Divide everything in the last one by 5, so we have 2, -1, and -1. All right, so I now need to get a 0 here. Should be simple enough because I've got a 1 above that. If I do -2 times row 2 and add that to row 3, let's see what we get. Okay, so we're just going to copy this guy. So we have 0, 1, -1/2, and -1/2. All right, so -2 times 1 is -2 plus 2 is 0. -2 times -1/2 is a +1, plus -1 is 0. -2 times -1/2 is +1, minus 1 is 0. All right. So we see here that we're not going to be able to get something in row echelon form. We did the process and the procedures correctly, but instead of having a 1 here, we have a 0. Now, what that means for us is that we have an infinite number of solutions. Now, we talked about this before. If you end up with something that's a true statement, when all the variables cancel out, usually 0 equals 0, it's going to be true, and you would have all real numbers being, or you would have an infinite number of solutions, and we talked about how we write that. If on this bottom row you have 0, 0, 0, but this is something that's not 0, then you're basically saying that 0x, 0y, 0z is equal to something. But 0 can only equal 0, right? So if it were to be like a 2, there'd be no solution. But as it stands, there would be an infinite number of solutions. So we've got to figure out, how do we do that? Well, as we've done in the past, we usually just pick a variable and let that guy be the leading man. So let z be any real number. Well, what's y going to be? Well, that's where we take this equation right here from the row echelon form. That's going to mean that y minus half z equals negative 1/2. So when you solve that for y is equal to positive 1/2 z minus 1/2. So you've got z, you've got y. Now we need to find out what x equals. And you've got a lot of options here in terms of how you want to do this. If I take this equation right here, so this becomes x minus 3y plus z equals negative 1. Getting x by itself would make this become positive 3y minus z minus 1. And we already have representations for y, and we know that z is just going to be z. So make those substitutions. So it's going to be 3 times 1/2 z minus 1/2 minus z minus 1. All right, so we get 3/2 z minus 3/2 minus z minus 1. All right, so 3/2 minus 1 for the coefficients of z gives us 1/2 z, and then taking negative 3/2 and negative 1 gives us negative 5/2. So that is going to be the representation for x based off of z. So the way that we write our solution set is it's going to be the set of all ordered triplets x, y, z such that the x is going to be half of z minus 5/2, y equals 1/2 z minus 1/2, and z is a real number. So any ordered triplet of that form is going to be a solution. Again, you can just pick a value for z and come up with an ordered triplet, and you could check it and make sure that it works out. So for example, we could say if z were to equal, let's say 7, right? So if I plug in 7, that means, let's see, if I plug in 7, there's going to be 7/2 minus 1/2 is 6/2. That means y equals 3. If I plug in 7 here, 7/2 minus 5/2 is 2/2, so that means x would equal 1. So one possible solution would be 1, 3, 7. And again, you can pick any number for z and find a solution. So if z were to equal 0, then y would equal negative 1/2, and x would equal negative 5/2, giving you the ordered pair, negative 5/2, negative 1/2, 0. So these are two possible solutions to that system because there are an infinite number of solutions. Okay, hope that made sense. Hope you are paying attention to what happens when you end up with a weird statement here for your last row when there should be a 1, but when all the variables go away, analyze it. Is it true? Is it false? If it's true, there are an infinite number of solutions. You got to make sure you know how to write them correctly.